section 4.2, we're doing exponential functions and graphs. So first of all, they give us this equation and they ask us to graph at number 1, y equals 2x. So I set this table up. I have my x value here, which I'm just going to pick some basic values. I'm going to use 0, 1, and 2. Okay, that means if I take since y equals 2x, I put the 2x here. If I put my 2, and everywhere x is at, I'm going to put a 0. Anything raised to the 0 power is just 1. So that gives me the ordered pair. I take my x and my y, 0, 1. For this next one, I have when x equals 1. So I take my original, my equation, 2, and where x is at, I'm going to put a 1. Well, 2 to the first power is just 2, so I get the ordered pair 1, 2. In my last one, I take 2 and I raise it to the second power, so 2 squared is 4, so it's the ordered pair 2, 4. If I sketch those, I get 0, 1, 1, 2, and 2, 4. The graph of this equation looks like that. That's an exponential equation. Next, we're exploring the number e. We have e on our calculator, so if you can find it, when you put e to the first power in, you are going to get 2.718. That's approximately what e equals. So then you're going to do e raised to the 10th power, e to the negative 3.7. Anything raised to the 0 power is just 1, and then e to the 5th power. So take a minute and play with that and plug them in your calculator and then check your answers. Okay, how'd you do? That's just the calculator problems. Plug those in, make sure you get those same values. If not, check to see what you're doing wrong and try again. Okay, we're going to do the graph of this one again. We're going to pick some values for x. We're just going to pick some easy ones, 0, 1, and 2 again. We're going to substitute them in. E and now x for this one is going to be 0. Well, anything raised to the 0 power is 1. So this is the ordered pair 0, 1. The next one I take e, and this time I'm going to put 1 in place of x. So e to the first power, as we looked at a minute ago when we put in the calculator, we're just going to round to 2.7. So it's the ordered pair 1, 2.7. Now if I do e to the second power and I plug that in my calculator, I'm going to get approximately 7.4. So I get the ordered pair 2, 7.4. When I graph that, I get here 1 comma 2.7 is about there, and then the ordered pair 2, 7.4, so that's somewhere in this area right here. And then we want to draw a sketch of it, and that's our graph of this one. Okay, our last problem is a compound interest formula. It's an application problem. Basically, this explains what's going on, and this is our formula. P is our principal amount, the amount we start with. R is the interest rate, we need it as a decimal. N is how often it compounds. If it compounds annually, it's going to have a 1. Semi-annually is going to be a 2. Quarterly is going to be a 4. Monthly is going to be a 12. And daily would be 365. So next we're going to look at our problem. It's going to say the parents of a newborn child invest $8,000 in a plan that earns 9% interest, compounded quarterly. If the money's left untouched, how much will the child have in the account in 55 years? So we're going to say our P is 8,000. It's our amount we start with. Our R is, the rate is 9%, but we have to write that as a decimal, so we move it 2 places to the left and we get 0.09. Our N is going to be periods. It says compounded quarterly, and quarterly means 4 times a year. And then we also need to know our TOM. Our T for Tom is going to be 55 years. So using that information, we're going to plug that into our formula. So we're going to get A is equal to 8,000 parenthesis 1 plus 0.09 divided by 4, and then our N is 4 and our T is 55. Okay, so now we need to plug that in our calculator and find out how much the amount's going to be. Okay, I pulled the calculator up because the order of operations is important when you're substituting this in. The first thing I did was I did 4 times 55 and I got 220. Now I want you to follow with me. I'm going to start here and I'm going to do 0.09 divided by 4. I'm going to get an answer and then I'm going to add 1 to that. Okay, after I get all of this value, I'm going to raise it to the 220th power and get an answer. After I get this answer, then my last step, multiply by 8,000. So I'm going to do that now. So I take my 0.09 divided by 4 equals, you get an answer. Now I need to do plus 1. So I do plus 1 equals. Now I take all of that answer and I raise it to the 220th power. So that's raised to the 220th power equals. Now I take all of that and I multiply it times 8,000. And then I'm going to write that answer down. I'm going to round it to the hundredths place since we're talking about money, and write that down. Okay, so we found out that our amount in the account after 55 years will be $1,069,103.27. Now, if I wanted to know just how much I had in interest, how much of that accumulated, I'm going to subtract the original amount that I had put in it. Well, we had already put in, well, the parents had already put in 8,000. So the way we find out how much interest was you take this value and you subtract 8,000 from it, and then you will get the next value. So we see this, subtract 8,000, this gives us our amount of interest that we made in the given problem.